Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we kickstarted with the statistical properties, especially with the first one, that the OLS estimators are unbiased estimators of the beta null and beta 1 of the population, giving us the mathematical way of writing it in terms of the expectation operator. We looked through the first two assumptions that are needed to get to the first statistical property. And in this particular case, we talked about assumption 1, linearity, and assumption 3, which was the variance of x being bigger than 0, or in the case of the multiple regression, no perfect collinearity, as the two most basic assumptions that gave us the existence of the OLS, which meant that I know I can do the maths now, but whether these are reliable or not, that's not the case because I still need a few more assumptions so that I can say that my first statistical property has been fulfilled. So let's see what are these additional assumptions that we need now that we know that the math is possible in principle to be done. I'll start with the second assumption, and that says that the sample is random. Meaning that if you have I1 to n, and you've got both xi and yi, we'll have a random sample of the population generated by some data generation process, basically, that looks y being some function of x, and then the noise. Okay? It's a very simple, but at the same time, very powerful assumption. This is literally the random sampling assumption. And it is very important for OLS because, one, it gives meaning to the whole idea that the population regression function exists, basically. It allows you to treat any sample averages as estimates, basically, of the population expectations. And at the same time, it prevents patterns that arise just because of the order of the data. Okay, so for some of you who might be asking, but Lydia, why was this not then one of the basic assumptions required for the OLS existence? Keep in mind, when we said the OLS existence assumptions, we simply needed enough information for us to say, okay, Stata will be able to do the computations, or even if I did the computations by hand, I will be able to do them. And I was not preoccupied at that time whether they were reliable or not. However, now that I want to add on to that reliance because I want those OLS guarantees because of those properties that I like of the OLS, now I'm going to add assumption 2, that is of the sample, the sample is random. One thing that I am going to note for every one of you before I jump into assumptions 4 and 5 is that assumption 2 will disappear with time series type of data because it doesn't really make sense for time series type of data to actually fulfill the random sampling, especially when you have, let's say, prices that depend on the price that you had the day before and so on. Okay. So just keep that in mind going forward. The fourth assumption is that of the unconditional mean of the error term, and it says that the unconditional mean of the error term is 0. Mathematically, we can write this as the expectation of the error term being equal to 0. What does that tell us is basically that on average, we expect the epsilon to have value 0, okay? Keep in mind, this is very different from the conditional mean, which we have seen in other videos. And the conditional mean is actually the fifth assumption. But before I introduce you to the fifth assumption and why it is one of the most important assumptions, I just want to make sure that you understand in some of the books, most of the times, this fourth assumption might be completely disregarded. And the reason for that is because it is weaker as an assumption and not enough for unbiasedness. Okay? So it means that if you have on expectation the error term equal to 0, you cannot imply, unfortunately, that the conditional expectation as well is going to be 0. Meaning that you can actually have a case where this is fulfilled, but this is not fulfilled. Think of it this way. People with higher education have systematically lower error term, but overall, average of the error term across the sample is still 0, which means that the OLS in this case will not be unbiased. So the unconditional mean is one of the conditions that is mostly mentioned, most of the times gets bypassed because it's weaker than the fifth assumption, which is the conditional mean. However, because of the importance of the expectation of the conditional mean, I will stop here for this video and introduce you to the last one in the next video and also show you finally how all of these 5 assumptions together give you the first statistical property. I hope this was helpful, and I'll see you in the next video.